A new type of exoplanet, one made half of rock and half of water, has been discovered around the most common stars in the universe, which may have great consequences in the search for life in the cosmos. Red dwarfs are the most common type of star, making up more than 70% of the universe's stellar population. These stars are small and cold, typically about one-fifth as massive as the Sun and up to 50 times dimmer. The fact that red dwarfs are very common has made scientists wonder if they might be the best chance for discovering planets that can possess life as we know it on Earth. Astronomers that discovered Gliese 887, the brightest red dwarf in our sky at visible wavelength of light, may host a planet within the habitat zone, where surface temperatures are suitable to host liquid water. However, whether the world orbiting red dwarf are potentially habitable remains unclear. Small exoplanet, one less than 4 times Earth diameter, orbiting Sun-like stars are generally either rocky or gassy, possessing either a thin or thick atmosphere of hydrogen and helium. Stars are much brighter than their planets, so astronomers cannot see most exoplanets directly. Instead, scientists usually detect exoplanet via the effect these worlds have on their stars, such as the shadow created when a planet crosses in front of its star, or the tiny gravitational tug on a star motion caused by its orbiting planet. By catching the shadow created when a planet crosses in front of its star, can find the diameter of the planet by measuring the small gravitational pull that a planet exerts on a star. Astrophysicists ultimately analyzed 34 exoplanets about which they had precise data on diameter and mass. In addition to 21 rocky planets and even gassy planets, they found 6 examples of new type of exoplanet, watery, which is made up of about half rock and half water, either in liquid or in ice form. It was a surprise to see evidence for so many water worlds orbiting the most common type of star in the galaxy. It has enormous consequences for the search for habitable planets. The rocky planet may have formed from relatively dry material near their stars. In contrast, the watery planet-like arose from icy material and were born far away from their star. Past the ice line where surface temperatures are freezing, they later migrated closer. The gassy planets are also water-rich and may have formed in a similar manner to the watery planets. However, they likely initially possess more mass and could therefore gather a hydrogen and helium atmosphere around themselves before venturing inward. Although the rocky planets are relatively poor in water and watery planets rich in it, that might not mean the former are arid and the latter are covered in ocean. That is, Earth only has 0.02% of its mass in the form of water, which makes it from the astrophysics point of view a dry wood, even though 3/4 of the surface is covered in water. In contrast, although the water planets are discovered are half water, that doesn't necessarily mean that they have massive ocean on the surface. The water seems mixed with the rock. A new generation of instruments in ground-based telescopes, especially in the US and Europe, are going to enable us to make this measurement. Another direction to follow up on the investigating the composition and properties of these watery worlds with the James Webb Space Telescope. We can analyze their atmosphere, if they have any, and see how they store water, a lot about their formation and evolution and internal structure.